Hi guys, I'm going to do the video number 5, and this is going to be about projectile motion. So let's see what we did in the class yesterday, meaning Tuesday, and then we can take it from there, and I'm going to give you one or two examples and then wrap it up. Okay, so I'm not going to do a long video. So this is what we did in the class. So I have x and y axis. I mean, I'm just going to do it, go over that briefly. And then I have a vector, and this time I'm going to call it B. In the class I called it A. It doesn't really matter what you call it. And then what we did was we drew these lines. One is parallel to the x-axis, the other one parallel to the y-axis. And we called this length, the one parallel to the y-axis, as B of y, and the other as B of x. And after that, what we did was we just took that triangle to a side, and then we have it as B of y, and then B of x over here, and the hypotenuse, because this is a right triangle, angle is theta, measured in counterclockwise direction, and this hypotenuse is what we have as B, right? So you remember that. And then we discussed the SOHCAHTOA. I'm going to write it again, that here, SOH, CAH, and TOA. So in the class, I showed you what the sine theta look like, and then sine theta equals to opposite over hypotenuse, and by doing a cross multiplication you can get the y component. We call this y component of the vector B, and that equals to B times sine theta. And then I asked the class to put a box around it, because this is an important thing, and this is the y component of vector B. Okay, and then the same way we did the cosine theta, and the cosine theta is, let's go to the SOHCAHTOA again. CAH, is the adjacent in this case is the B of x, and the hypotenuse is B. So when you do the cross multiplication and isolate the x, bx onto into one side, you get bx equals to B cosine theta. The most important thing here is to understand that the angle is measured in the counterclockwise direction with respect to the axis x, positive x. And then B is the magnitude. So these are the two important equations that we discussed, and one is the y component of the vector A, vector B, and the other one is the x component of the vector B. What this really means, if you just look at it, here's what it really means. This is vector B, okay, and it is making an angle with respect to the x-axis, and the angle is given as theta. So we can represent the same vector using the following components. So these are identical. On this side you have B making an angle, and that is equal to the x component of the vector plus the y component of the vector by. And if you just look at this, I hope that the yellow color works here. Now this is what it does. So if you remember, we were looking at the vector addition, and this is bx, this is the tail of the vector, and here is the head of the vector, and we take the tail of the second vector to the head of the first vector, and we place it right there, and there you have the y vector. So we have added the two, and this is the initial point, this is the final point, and we draw a line like that, and that actually represent the vector B, or that is shown over here, right? So if you only have this yellow color arrows, one along bx and the other one along y direction, which is by, then that actually represents the vector B. So that's the basic idea. Now, in order to find the angle, again, I am drawing the triangle, or I can actually use the one over here, but you know what? I'm going to draw it. So here goes the right triangle, and this is bx, this is by, and this is B, right? So B is the, I'm just circling it on this side, B is the magnitude of the vector as we discussed in the class. So let me write it here. B is the magnitude of the vector, magnitude of the vector B. Okay, so I'm going to find that magnitude using this angle. This is theta. It is not really necessary in this case, but I'm using the Pythagorean theorem, and that gives me b square equals to bx square plus by square. Now to find b, you take the square root on both sides, and this is what we get. So this is the equation that you need to find the magnitude of vector b. Okay, that also you have to have a star right next to it. Now the last thing that we discussed was the angle, and the angle gives you the direction. So I'm going to go to the next side. Let's see, a new page. I'm going to open a new page and see if I can go to the other side and continue this. And yeah, here we have the triangle again. Here we are going to find the direction. This is bx, this is by, and that is b, and the angle is theta. So you can actually use any angle, sine theta, cosine theta, or tan theta, but people always use tan theta when finding the direction. Again, there is no preference. Tan theta equals by over bx, opposite over adjacent. So you take the inverse of tan in order to find the angle. So this gives you the direction, and always remember, when you have the angle drawn in this form, the opposite always is the y component and the adjacent is always the x component. And throughout this class I will take the x-axis, the angle going in counterclockwise direction measured with respect to the positive direction of x-axis. Now that we have all the information, let me actually give you a makeup like a question for you. Okay, so let's say question number 1, and the question number 1 gives you a velocity vector. So a velocity vector, and it has a magnitude. So the magnitude of the velocity vector, magnitude of the velocity, it's a, let's say 25 meter per second, and the angle it makes with the positive x direction. In order to make the video short, I'm just writing it down, only the information that I need. And the angle theta with respect to WRT means with respect to the positive x-axis, I'm going to take it as 30 degrees. All right, so the question asks us, what is the x component of the vector, meaning what is vx and what is vy, the y component. So we are supposed to find the x and the y components. So it's always best, since we are at the beginning of this chapter, we can always draw a little like a diagram, and then show that this is the v, velocity vector, and it is pointed along the angle 30 degrees measured in counterclockwise direction, and this is your positive x-axis. Now in the example that I did in the previous page, I took the letter B, and B was just a random letter that I picked from the alphabet. But here we are looking at the velocity, right? So the velocity usually is represented by the letter V. Therefore, I am going to use the letter V here. And the velocity vector x component equals the magnitude of that vector, which is the velocity, equals, times cosine theta. So let's substitute what we know. V equals 25. That is the magnitude right over here. That gives the size of that vector, which is the magnitude. And then the cosine theta. Cosine theta in this case is cosine 30. We just check that it is measured with respect to the positive x-axis going in the counterclockwise direction. So that's checked. And using this, you can find Vx equals 25 times cosine 30 is 0.86 roughly. and the unit goes as meter per second. So I don't want to actually stop my video over here. You guys can go ahead and find the calculation. I mean, using a calculator, you can find what 25 times 0.86, and that is the x component of the velocity vector, okay, as a number, and the unit stays as meter per second. And then similarly, the y component of the vector is given by v sine theta, and v is again the magnitude 25 meter per second. Sine theta is sine times 30, and there you will have 25 meter per second times 0.5. Sine 30 is 0.5, and that I can actually do the math in my head, which is 12.5 meter per second, and that is your y component of the vector. So when the magnitude and the angle are given to us, you can find the x and y components of the vector. So that's what it says. And the last part of the video is, let's say that the components of a vector is given, and you are supposed to find the magnitude of that vector. So I am going to take, this is question number 2, or just like, you know, the example number 2, whatever you want to call it. Question number 2, and that gives you the acceleration, x component of an acceleration as 8 meter per second square, and that also gives you the y component of the acceleration as 6 meter per second square. And the question asks us to find the magnitude of the acceleration vector as well as the direction. So magnitude of A, and A is the vector here, and the direction. So again, we know all the equations that we need, and if you want to use the graphical analysis, that also can be done. But let me first use the equations that we have. And on the first page, I use the letter as a symbol B, and then I found out the magnitude of the B vector was square root of bx square plus by square. But in this case, we have A as the vector, which is the acceleration. I mean, when you look at the units, you can see that it is the acceleration. And there you have A equals ax square plus ay square. If you do, if you substitute the numbers and then square them, add them, take the square root, let's see what happens. Here you have 8 square, and there you have 6 square, and that gives us a square root of 100. Don't forget the unit stays as meter per second square and meter per second square. So the acceleration, I shouldn't actually write the, let me erase this sign shouldn't be there, the vector sign, it's not erasing. There you go. So the vector sign shouldn't be there because I am looking for the magnitude. So I erase that, and let me write the A again. And that gives us 10 meter per second square, and that's the answer for the first part of the problem. And then the second part asks us to find the direction, and direction is given by tan theta, and that equals to y component of the x component. So I was actually writing by. We don't have to write by, we can simply write a in this case, a y over ax. So theta equals, or tan theta equals, what is ay? 6, and ax 8, and theta is the inverse of tangent, and there you have it as 6 over 8. You can substitute, I mean, you can use your calculator and finish up this work, and that gives the final answer for the direction. Now at the beginning of the question I said that you can even use the graphical analysis. Well, by that what I meant is the following. AX has pointed along this direction, AY is pointed along this direction. So in the last class I showed you how to draw these vectors and the proper way when you are adding them, right? So here you have AX, and the second vector starts from the head of the first vector. So this is the AY vector, and this is the initial point. Here's the final point, and what I am doing is I am just joining those 2 points, and that gives my magnitude, right? That's what we already know. So here AX is given to us as 8 meter per second square. AY is given to us as 6 meter per second square. And this is the hypotenuse of the right triangle, which is 8 square plus 6 square, and the square root of that. And that alone gives us the same answer as before, 10 meter per second square. So this is what I expect you to know for the quiz the next day. All right. So if you have any questions, email me.